Right, good morning, everybody. A really warm welcome to all of you. We've got a great webinar ahead, and we'll introduce Joe shortly. But as we've advertised, this week we are going to be talking about net zero carbon design, and more specifically what Joe and FCBStudios have been up to with some case studies and bits and bobs thrown in there. But before we get into that, just a bit of really quick housekeeping and a couple of announcements for you guys. Housekeeping wise, kind of etiquette, do keep your mics on mute. You're more than welcome to turn your videos on, but don't mind if you don't want to. And as I say, if you've got your mics on mute, then that really makes sure that everybody gets the most out of the experience. We haven't gotten talking over and cross chat. A quick reminder that this is being recorded. This is going to go up on YouTube by the end of the day, so do check out our YouTube channel. We've got loads and loads and loads of these webinars on there now. Do subscribe to that YouTube channel so you get the updates. As I say, all the content that Jack is sharing, Joe, apologies, Joe is sharing today, we'll also share with you guys by way of the email mail out, which again will happen by the end of the day as well. So without further ado, just a couple of bits here. If you're new to our webinars, Mesh Energy is an independent and holistic energy, renewable energy consultancy practice. We're based in the south of the UK, but do projects throughout the UK, Europe and beyond. But fundamentally, we're interested in partnering with design teams to make sustainable buildings more successful. And we're not biased in any way. We've got a huge amount of experience and a massive toolkit at our disposal. And as I say, really trying to make the most of the architecture and make sure that we can get you to a more successful, sustainable design more quickly and more rapidly, and make sure you benefit from all of our experience. And one last final thing before we get on to the webinar. I'm delighted to say that today, all the hard work that we've put behind MESHWORK is actually launching for a select few of you guys, and some of you guys may be on the webinar. But if you have been on these webinars over the next few weeks, we're going to invite you into this platform, and this is a community of professionals who are serious about sustainable design in the built environment. We've got specialists there, we've got people who know absolutely nothing. It's all about asking questions, getting connected to the right people, sharing relevant news articles, learning from various webinars that we'll be sharing as well as our own, and really about education. So making that social education and sustainable design crossover. We're really excited about this. And as I say, this month is for you guys on these webinars. Next month we'll be opening it up to everybody, and hopefully you can invite who you think that's appropriate for. That's enough from me. I'm going to let Joe introduce himself and get on with the presentation. But by way of a very, very brief introduction, Joe's an associate at FCBStudios. He's in charge of research and sustainability. A lot of you will probably have heard his name because he does a huge amount for sustainability in the built environment, and certainly FCBStudios' name is out there in lights as well. So Joe, without further ado, I'm going to hand over to you. I will stop sharing my screen and give you the opportunity to present there.
Great, thanks, Doug, and hello everybody. Yeah, I just as a kind of quick preamble, so I work at Feilden like Bradley, and I obviously do a lot of talks, and I'm very happy doing an awful lot of talks. It's always nice to have a captive audience, but I think CPD sessions like this are just so incredibly important. So I'm always happy to support this. So I think, if you do find yourself, find this on YouTube, subscribe. It all helps sort of keep this going. There's not enough knowledge sharing in the industry. We spend a lot of time talking about how the industry has an awful lot of inertia, and one part of it is we don't share that knowledge we have, and it is key. You still need to remain competitive, but I do think there's fundamentals of sharing knowledge on sustainability is what we all have to do to kind of overcome that. So do if you see something like this, go along to it, support it, let other people know. But also, if you've got a bit of knowledge and you think, great, how can I share this? You know, do shout, do have a look. Things like the MESHWORK, really great opportunity. So I'm going to share my screen, which is a very conveniently color coordinated with my jumper today. Not always deliberate, but occasionally. Doug's just noted in there, like, do throw your questions in. I'm going to try and wait to the end to do the questions, only because I'm going to try and whistle through it, but I'm more than happy. These things are always far more interesting if there's questions and discussion that comes around it. And I've kind of put in some little key bits, which I think probably maybe not quite controversial, but probably a bit more usual. And we can see where we get to with that. But do feel free to ask a really difficult question. I'm more than happy to be put on the spot, and it's always fun to see the speaker kind of wriggle and squirm. So that's kind of good fun. Cool. Okay, so you should all be able to see this. I'm going to talk about FCB and our kind of route to net zero, some of the things and tools we do. I've got a few case studies in there. Probably thinking about it, probably should have put a few more in, but I thought it was kind of interesting. I get a lot of questions about actually what do FCB do. So I just wanted to kind of flag this up and really talk about some of the bits that we get stuck into. So this is us, FCBStudios. For those that don't know us, we're a large architectural practice, we're about 200 people, offices all around the country. So we've got London, Bath, Belfast, Manchester, and a small one in Edinburgh. And we do all kinds of different buildings, you know, schools and higher education. Housing, famously Accordia won the Sterling Prize. And we do lots of heritage. But really beyond that, we've been looking at sustainability for the past kind of 42 years, 43 years probably. Back when sustainability was less of a thing, and actually it was about the energy crisis and running out of oil. Oh, apparently I've got an animation on there. So what's interesting off the back of that is we moved from that, you know, not having enough energy to kind of how do you make a sustainable building off the back of that? And we started looking at things like passive solar design, and we started looking at solar and ventilation control. And it's really all about operational energy and how do we get that going until sort of the early 2000s. So you can see there's things like the BRE Environmental Office and some of the bits and pieces here. Bedales Theatre, which is still fantastic, you know, it's still a great building. From there, we moved into sort of a slightly broader sustainability, looking at One Planet Living. So really starting to think, okay, you know, we've got energy, kind of the ideas of low energy design going. What about all the other bits and pieces? And we'll talk a little bit about that at the end as well. And then we started really focusing on really drilling down into that performance gap. So we worked on things like carbon buzz, and we've got our own system called Energy Tracker. We start to think about how we can drill into it. How do we design for real performance? You know, and that's, you know, I come to the fore again in this, you know, actually design performance led by Better Buildings Partnership and Verco and others. But what's not on here is this. Now we're moving away from, we still have passive house and passive house training. We're still training people in passive house, but really looking at things like embodied carbon. And it's a new thing. We'd always been looking at natural materials, but it's kind of taken us a bit as a kind of sideline. And really the sort of renewed focus comes off the back of Architects Declare. So we're one of the founding signatories. Peter Clegg is part of the steering group. I dip in and out every now and then. I try to avoid it, you know, in terms of time. But there's now 1,000+ practices signed up to it. And in fact, Construction Declares, I think, is operating in 16 countries. So there's Building Services Declare, there's Landscape Architects Declare, there's Structural Engineers Declare, there's Civil Engineers Declare. There's loads of different versions in each country, and all have signed up to very similar, certainly within the UK, very, very similar, 11 points. And these outline things along, you know, talking about biodiversity crisis, operational energy, low carbon design, low embodied carbon design, but also bits about regeneration. And a really key one, sharing knowledge. You know, again, you know, as I started, sharing knowledge is the key to overcoming the climate crisis. So really great, and it's fantastic kind of armature for it. And off the back of that, we went out and protested in September 2019. Feels like a very, very long time ago, and it probably was. And in fact, Team FCB is somewhere sort of dotted around here. I'm behind this sign, if you're wondering where I am. And this is outside the Building Centre in London, and we went out and joined the student protests. We all went on strike for a day. It's fantastic. All of these great signs were fine compared to the student signs, which are far, far funnier and far, far pithier. So, you know, we've still got a bit of catching up to do, but it's kind of reassuring that the students are a bit more engaged than we are. So that's kind of great. So we made this declaration, fine, we signed up to it, we sit in the steering group, whatever else, you know, we've been doing this kind of design, but what are we actually going to do about it? And we were one of the first practices, I think, to respond to architects declare in a public way. So if you go on our website in the climate section, it has all 11 architects declare points, and you can see exactly how we respond to each of those aspects. And this is our kind of summary of it, because nobody likes reading, you know, 1,000 words of prose, even if it is fantastically well written and flowing. And this is the kind of thing that's really sets, you know, keeps me awake at night. How are we going to get to net zero carbon buildings by 2030? And this is our really kind of key point here, 2025. So buildings starting on site are going to need to be zero carbon in some form, so that when they start on site, it's going to take maybe 2 years to build. Some of our projects might take a bit longer, some might be quicker. We know full well that when you build a building, it's, you know, in that first year, you have seasonal commissioning, you have the kind of the settling down, how people are using the spaces. So it can take up to 3 years to really meet its performance in use. So kind of interesting. So we're always looking for that, you know, that 5-year period. And this is aligned with things like LETI as well, which is kind of interesting. So the end of last year, so 2020, so that was March 2020, all projects up to RIBA stage 3 in the practice have alternative zero carbon plans. Now, really, this is more about us understanding how much carbon our buildings emit. So we spent a long time looking at our projects, understanding how much carbon they emit, and looking at things like PV offsetting. You know, is it forest? Is it something else? What's the kind of costs? So it's not really about zero carbon; it's about kind of offsetting. By the end of March, so this is financial years, just so you know, because that's the way the practice works. So this is the end of 2020, but it's actually March 2021. So in fact, in a month, all of our projects will have a One Planet Living action plan. So this is what's keeping me busy at the minute, going through all of our projects, make sure they have a plan. And this is a bit about saying, okay, great. So we already have the processes for understanding how much carbon's in there. So we did that last year. We keep that process going. And this year we're adding in another bit. Now, actually, we've been doing One Planet action plans for quite a while, but this is a bit more of a formalized approach to it. So we're going from, you know, a bit of a kind of procedural thing to actually really embracing it, and then starting to talk to our clients about it. So when we sit down with our clients at the very inception of the project, maybe it's kind of stage 1, we sit down and we say, this is your One Planet plan that we think you could do, and then we have something documented and we can start that discussion going and really start to think about how you make a building that supports a low carbon lifestyle, or, you know, sustainable lifestyle. During this period, we're doing lots of POEs or developing our POE toolkit. There's a long story about POEs that can go with it. Fionn Stevenson, I think, is talking next week or the next talk. Absolute expert in all of this kind of stuff. Really interesting. But the thing here is that it's all very well and good for us to design buildings, but we need to make sure they work in practice. And then, yeah, this is our target. So 2025. So I've basically got 5 years-ish to get zero carbon on all of our projects. And this is going to throw up lots of key questions. Are there some projects we just can't do? Do we embrace that? Do we still do them? How do we offset it? So it's going to throw up a whole load of methodological issues as we work through it. But we think we're going to be fairly public about how we approach these things. I think the learnings we find from this are probably going to be useful for everybody. So that's our practice plan. You can see it's online if you really want to pore over the numbers. It is published on the climate bit of our website. But I think what's kind of interesting is, you know, I've been talking about net zero already. But really, what is net zero? And I'm taking this to a kind of personal level, really. So those I'm sure of who are interested in net zero carbon have seen the UK Green Building Net Zero Carbon Framework. I think it's about the most robust in the UK. I do really like it. It talks a bit about construction carbon and it talks a bit about operational energy carbon. and those kind of two approaches. So construction being your embodied carbon, what are you making the stuff from? What happens to the end of its life? Where does it? How does it get transported? Whatever else. And the operational energy being the stuff that, the energy we use, the lights, the computers, all that kind of stuff. But I really like whole life carbon. I think we really need to think about all of it together. I think really we should be thinking about 1.1, 1.2, construction, operational carbon, and whole life carbon, and really joining them together. And I think this is where you get a really sort of powerful discussion. So this, I'm going to sort of quickly run through what we as a practice define as net zero carbon. So the first point of this slide is just understanding the importance of net in this kind of discussion. If you don't have it, zero operational carbon, fantastic. It's your kind of shack in the woods with a PV panel on the roof. Really great, but probably not hugely practical. We're doing big HE buildings. So really, probably what we're looking at is net zero operational carbon. So that energy we use over the course of the year, actually, we generate as much or more on site, usually through PV panels. It could be through a water wheel or something clever, or it could be through a wind turbine. Not likely to be a wind turbine currently. But having said that, that net zero operational carbon, maybe that wind turbine isn't on our site, maybe it's somewhere else. Somewhere windier, or somewhere, it's got less planning constraints, for instance. Definitely less planning constraints. So, that's our kind of net zero operational carbon definition. And I think that's a kind of straightforward one. Where it gets to net zero embodied carbon is where it gets pretty vague and a bit woollier. So we build a lot in timber. There are other practices who build almost exclusively in timber as well, and there's loads of good reasons to use timber. But when you start to think about embodied carbon in this kind of fashion, you see that there's some things that emit carbon. Everything's going to emit carbon in some form, almost certainly. There's always some energy to get it site. There's always some energy to cut it or form it into whatever you need. But some things will just sequester more carbon than they emit. So your timbers and your kind of corks and your bamboos and your whatever else. So you can end up in this position where you end up with a kind of negative embodied carbon, if you like. So you take up all those stacks above, you take it below. Now there's a whole raft of issues that come with this. And there's a kind of accounting scam that sits with sequestering carbon. So you have to be very careful about how you do it. So you need to report both. You need to do above the line and below the line. So if you have more sequestered carbon than emitted, you can be below line. And that's kind of how we define it. And we're kind of happy with that. This is our kind of simplified version of carbon sequestration. If your tree absorbs a unit of CO2, you chop it down, it might be 0.8 units of CO2 left. You've got some of that's emitted, some of it disappears to wherever it goes. It might be 0.6 units, but you've still got it. And what you're really saying is you're kind of offsetting within your building. Kind of amazing. Sorry, parcels being delivered. The wonders of working at home. But what happens is you can take these two bits together and you can have these kind of routes to zero carbon. And this is what we're trying to understand and how we get in terms of whole life carbon, how they kind of stack up. So if you have this kind of negative operational carbon, you can have a lump of embodied that's above the line. Maybe it's made out of steel or concrete. It's a more typical building, but you have a huge PV array on the roof, and maybe you have negative operational carbon, so it goes below the line eventually. So you have this carbon neutral period after a certain number of years. The second one here is negative embodied carbon. So some of you might have seen our Paradise project that got picked up. Seems to get picked up in things like Zine and things. And we have this kind of discussion about there's an awful lot of timber in the building. Does it become carbon negative? So it's tall, it's about 6 stories tall. We don't have enough space for PVs to make it zero operational carbon. So it's only carbon neutral for 40 to 60 years, something like this. So kind of interesting. The third one is the one we're really pushing for, and we call this a regenerative. So it starts below the line and it gets further and further away from that line. It goes more and more negative. So probably it'll be a timber frame building, and they'll probably have quite an extensive PV array on the roof. So that's our kind of, this is what we're aiming for when we're trying to do zero carbon buildings. Super tricky. Obviously, if it wasn't tricky, we just all have them. but there's a whole raft of kind of compliance that sits with it. Now, it's great to think about it in these kind of terms, but I would say we still have to really, we can't just throw PVs at a building and make it fine, and we can't just say, oh, okay, it's full of timber, so it's going to be carbon neutral. We can just use as much energy as we want. We still have to make low energy buildings, and that's still such a key point. This is from the LETI Climate Emergency Design Guide. If you haven't seen it, do have a look. Absolutely brilliant. And the point here is that LETI set EUI targets, so they use targets of 35 kilowatt hours per meter squared per year for a kind of average building, average domestic. Offices, it's about 55. So they're aligned with the RIBA targets, and I'll show you those in a second. If we use more than 35 kilowatt hours per meter squared per annum for our new buildings, we won't have enough energy to make low carbon electricity. Therefore, at best, our energy grid becomes more carbon emitting. We connect more gas turbines to it, etc., etc. At worst, we don't have enough power and we have rolling blackouts. So hugely complex. We can't just rely on having low carbon structures to make our buildings look zero carbon. They've got to be low operational carbon and low embodied carbon. Do them separately and then join them together. And this is where some of the RIBA 2030 challenge targets are really useful for guiding, and we use these internally to help us form our ideas. Now, I would say this is domestic at the top, non-domestic below it. Operational energy figures are pretty good. I do kind of agree with those. They're pretty robust. The embodied carbon figures are a bit flimsier, but I think they're fine. They're good for kind of targets. We expect to see these updated in the next 6 months. There's actually a project ongoing at the minute with UK Green Building Council. I think it's Tom Spurrier's leading it, about science-based targets for embodied carbon. What we expect to see very soon, probably over the next year, is that we'll start to see better and more robust figures that are really aligning with our kind of 1.5 degree global warming scenario and the kind of carbon emissions we need to reduce. So do keep an eye on that. One thing I haven't spoken about is this kind of potable water use. We, I think, as a country, aren't particularly great with water use. I think we need to get better at it. And I'm not going to talk much more about it, but it is worth a good look. And if you look at the LETI Climate Emergency Design Guide, they have nice little pages like this. This is a commercial office page. Super simple. It's a really nice start point. So they've got 4 typologies in there. They've got low density housing, medium and high density housing, I think, schools and offices. It's free. Just if you go to leti.london, that's the web address, you can find it and download it. They have energy targets, so it's 55 kilowatt hours for everything for offices and 15 just for heating. So semi-aligned to passive house. Gives you good ideas of how much glazing you'd need, PVs, form factors, systems you can use, a bit about embodied carbon, all in one page. Incredibly information dense, but incredibly accessible. A real triumph. Very much worth a look. And I just thought I'd just in here, just to make it a sort of come back to it, this is a project we did back in, I think it's 2010, 2012, somewhere around there. This is Woodland Trust HQ. Obviously, the Woodland Trust approached us and said, we'd like a building and make it out of timber. It's the Woodland Trust. Of course, we made it out of timber. And it's very timbery. Everything is timber. So it's CLT throughout with glulam beams. It's larch on the outside, and it's wood wall insulation. Absolutely fantastic building. And we were doing this before we were really accounting for carbon, and we did it because the clients really wanted it, and also we really like these natural materials. We had a little look at it and we sort of revisited it, and we think we save about 177 tons of CO2 through, we're at a kind of negative base. We think we saved nearly 650 tons compared to the concrete frame structure that we would have used. What I would say about this is actually it was such an efficient frame, and we actually reintroduced some concrete back into it and steel and rebar. So these panels here, you can see, these perform 2 bits of information. So they're 2 bits of kind of use. They are thermal mass, and they are also pulling the frame in tension. So what we actually have at Woodland Trust is 12 meter spans in CLT, which is kind of, probably pushing it a bit. but those concrete slabs, they're only about 60, 70 mil deep. I think they might be up to 85 in certain places. It's very thin. They look thick, but actually they have steel rebar that runs through, pulls that whole floor plate in tension, and stops it wobbling when you walk along. Because apparently people don't like floors that wobble when you walk. I can kind of sympathize that. So we have that kind of simple system, really good. But we took the best bits of concrete and steel and put it back in the building. Using materials the way they need to be used and really responding directly to how they could be used. Really great, super simple. We went back and did check it out. It is all kind of working. They had lots of issues with not opening the windows at night for night ventilation and things like this. And I'm sure when Fionn does the next talk, she'll be able to tell you a bit more about the POE stuff. But this was led by Bill Bordas and Adrian Lehman, the kind of gods of POE, if you like. Really interesting study. So there's a really nice, there's a question from Tom. FCBS CARBON, there's also Mesh have their own tool, which is also fantastic for estimating carbon, embodied carbon. And there you go. Thanks, Doug. It's like a perfect setup. And honestly, Tom isn't a plant. It just happens to be a question that came at the right time. And I suspect Doug came up with something very similar for the same reasons. What we realize is we need to be able to estimate how much carbon's in our buildings from the very beginning. This is the scale of FCBStudios last year. This is where our projects are up to stage 5, and you can kind of see this number of projects. This is each stage. There's obviously quite a lot of stage 5. I am not going to be that person that swans into the contractors meeting and says, right, we're putting timber frame in when they've been designing concrete. They'd probably kick me off the site at best, and I'm not sure FCBStudios would be particularly happy with me. And really, it does get progressively more difficult to make changes the further on you get. So really what we want to be doing is down this end here, talking to our clients, managing their expectations, really trying to work with them. And that leaves us in a point where probably stage 0 to 2, we can make changes kind of free, in terms of cost. It's just a bit of design thought. It's comparatively cheap. But that still leaves me with 40 projects a year I need to do embodied carbon calculations on, and iterative changes. I do another version of this talk, and if you look at it online, if you go to, and Doug's put the link in there, there's a video of me waffling through FCBS CARBON, and you can kind of see that if we did just 2 massings, I reckon I'd have to do 108 variations on a building. So 40 times 108, it's more than I have time to do. So really we needed a simple tool that would enable everybody to do them, but kind of collaboratively. And the kind of thing, when you were trying to work out embodied carbon tools, calculations, you need 2 bits of information. You need a bill of materials or quantities of some sort, and you need the embodied carbon of it. We can put standard embodied carbon figures in there. You can get them from the ICE database. It's kind of a good start point. EC3 in the States, I think has more UK materials now. EC3 is quite a good one. There's one-click planetary, all this kind of thing. So there are ways of getting good embodied carbon figures, but it's really difficult to get a figure for how much material you have in your building. So we used an algorithmically designed building. You put in a couple of standard things, and it gives you some figures about how the building performs. It's not perfect, but actually what it does is it enables us as a practice. So last year, when I said that we had alternative carbon plans for all of our projects, we used FCBS CARBON to make that. So it took half an hour for each of our project teams to put the data in, and it told them how many forests they needed, how many PV panels they needed. And it allowed me to put a kind of benchmark together of this is where our projects are, and this is kind of roughly where our kind of start point on our journey to zero carbon is. And you need that kind of estimation to understand how you move forward. The real reason for making it is that embodied carbon is a new kind of thinking for many people, particularly in the industry. I think there's a lot of sort of mystery about it, and how do you work it out? And what I really wanted to do is enable the architects to start to think about it within FCB as a start point, and then we released it free because we realised that it's probably not much use if it's just us, smashing out zero carbon buildings. We probably need everybody to do it. So there is a free one out there. So there's a bit of kind of education, and we realised that in order to do that, there are other great tools out there that connect into BIM. So HBERT, which has been released by Hawkins Brown, is fantastic. If you've got a Revit model, you can plug it straight in there and it'll give you some great figures. You have to use their kind of systems. That's great, you know, as a kind of estimation. Lovely, really good, really quick. But I was really interested in just getting people to make those initial guesses. So I did it in Excel because I'm an absolute sadist and love Excel. But the other thing is, through using Excel, there's no real barriers. Everybody has access to it, and everybody can start to understand you. You can share that spreadsheet with your client. You can share it with your engineers. You can share it with your, you know, your planning consultant, whatever. Even send it on to your, you know, externals, whatever. But it means that everybody can get an idea of when you make a simple change, is that a change for better or for worse, and how much better or how much worse. You know, within FCBS Carbon, you can change the render from a cementitious render to a lime render. Now, there is a slight change, you know, but if you're fanning around with the renders, you're in a great position. You should have already fixed all your kind of structure and all that kind of thing. So understanding where your embodied carbon is really does help you. You know, you can tinker with these little bits and pieces, but you need to make bigger changes. I won't go through all of FCBS Carbon because there's an awful lot of tedious to it, and there's other talks me talking about it, and it's not really, you know, it's not why I'm here. But it does have, it's got kind of 3 bits to it. There's a bit of overview, there's a bit about operational energy. The operational energy stuff is pretty dumb. You just put a figure in. We're all working on that. And there's the kind of embodied carbon bit, and then 2 outputs. And what we have here is things we input on the left and the kind of building elements on the right and how they interface. Kind of interesting to see when you change certain things, what they do change in the algorithm. This is kind of a useful table for us. So I show it quite a lot when I'm talking to people about it. You know, if you change the perimeter of your building, what does it kind of work out? And again, I don't think FCBS Carbon is hugely accurate. I think it's fine. I don't think it might be a bit generous in certain situations, might be a bit overkill in others, but it enables us to have that kind of, you know, what happens if you add 300 mil onto a floor-to-floor heights, you know, that kind of movement. And these are the outputs. So in the top left here, now you probably can't read this because it's tiny, but in the top left here, we have operational energy. This is our life cycle embodied carbons. This is modules A1 to C4. So from cradle all the way to grave. Some sort of whole life carbon impacts, you can 30, 60, 90, 120 years, you can see over the course of life, and a bit about offsetting. This, just draw your attention to the bar at the top. So this here is against the RIBA 2030 challenges, and you can see the black line here is for your energy use, and the grey line here is when you start to include things like PVs and how you're offsetting. So we should always be looking at, A, does the building use, how much energy does it use just by itself, and then how much are we offsetting. Similarly, the embodied carbon, we've got this kind of black line here, which tells us how much carbon it emits through the building. And then another one here, which is our kind of sequestered carbon. So we're always making sure we're reporting both, and you can see that kind of here. And then there's a bit more of a detailed output for those that really like to get into it. I spend most of my life on this sheet. It tells you by your life cycle modules, what's kicking it out, what's absorbing it, you know, your kind of biogenic bits here. Now, this mostly follows the RICS professional statement, and it also follows the BSEN 15978 that kind of guides life cycle assessments. The one thing I don't have in here is in module C1, C4, all of your biogenic carbon is assumed to be burned at the end of its life. So you take your timber, you take your building down, you chuck it on a big bonfire. Hopefully you recover some useful energy from it, maybe not. So these should balance out. So you kind of have a net null effect, if you like. Now, I don't think we should be burning buildings at the end of their life. I certainly don't think we should be doing it 60 years. So we don't model it in there. Just as a caveat, so if you do use FCBS Carbon, be very careful when you start to use sequestration figures, because you might find you get caught out when you move to different tools. Here is just the kind of life cycle carbon, whole life carbon. It starts where your embodied carbon thing is, so very much like those graphs I showed earlier, those indicative ones. Each of these little lumps is to do with replacement cycles. So every 20 years, something in this building has been recycled or replaced. Could be services, could be a big one. 80 years is obviously something major is getting replaced. And the red line here is current grid factors, gross energy demands. We're not accounting for PVs. There's no carbon sequestration. And the green line is like the optimistic one. where we include sequestration. We have the decarbonising grid. We include our PVs. So, you know, in reality, your building will be somewhere within here, depending where you want to see it and what you kind of think, what your kind of philosophy is. So just to show you how that kind of works in the project. So this is Croft Gardens. It's in the ground at the minute. It's up in Cambridge, King's College. Really fantastic student housing project. CLT structure. We were given a brief of a 100-year design life. And we've really literally taken it as a 100-year design life. So we're really designing things that will last for 100 years. But more so than that, there are things we can design, but they just won't ever last 100 years. So triple glazing panels, for instance, they could last 20 years, they could last 30, 40 years. They won't last 100 years. So actually, how do you replace those? And really designing this kind of idea in of, you know, maybe having an exposed screw somewhere isn't the end of the world if you can actually, you know, inform somebody in 20, 30, 40 years when the O&M manuals have long gone. You know, they've been found in a puddle in the services room next to the boiler or something, so I tend to find them. You know, what's happened to it? And it's a kind of CLT structure. We came up with this idea of, you know, it's a balance of materials. So we have this CLT frame and structure. On the outside, we have this kind of ceramic skin. So it's brick. You know, we know brick lasts for 100 years, 150, 200 years. So really having this kind of robust outside, and could we start to balance it? And this is a model we made for the RA. I didn't think you won an award. Bit of a shame. Anyway, you know, we can start to see what that balance is between the two. So when you can see inside and you can see the outside, really quite a, kind of an interesting story to go with it. And this is where we kind of got to. So this is our zero line. So using those graphs that we used to describe it, we start below the line at about minus 350-ish, and we cross over about 40, 41 years. We've got some replacement cycles modeled in there. You can see this start to pick up. I think this is our structures model that's been replaced after 100 years. Not quite sure, which isn't too bad. You know, 40 years of net zero carbon, it's not bad, but we're aiming for a bit longer than that. So Nick, the project architect, has been really slavishly digging into all the different kinds of numbers and bits and pieces. So what about if we added some PV? So looking at this, it's always difficult to add PV on buildings when it's already in the ground. You know, you need to go through planning again. But we're adding 12.5 kilowatt PV array because it's so low energy in the first place. Actually, we could start to push it out to 60 years. Pretty good. Curvy roof bit with PVs on there, probably not the ideal thing, but it's probably not too bad. But what if we took them out, replaced it with a 10 kilowatt battery? So we're going to have EV charging on site, so it kind of makes sense. So we can achieve something very similar if we start to, you know, buy carbon, you know, at low periods, or, you know, buy our electricity at low periods when it's, you know, the grid's better, rather than buying at high periods. So we start to really think about those kind of ideas. So yeah, similarly, we can get down to 60 years. And what's really nice about this is we can kind of see it kind of straightforward. So that's carbon, and I think carbon's incredibly important, and I think that's why we're all focusing on it. But I do think we still need to be really aware of those other broader aspects. And I mentioned One Planet Living at the start, and this is our kind of global footprint within the UK. So the idea, if you haven't come across global footprinting, we can come back to it, but the idea is roughly, you know, everything we do has an associated area of land or sea that comes with it. So we currently use 3 planets worth of land in the UK, if you all consumed as we do. And that's mostly home energy, you know, about 22%, so that's great. We can sort that out of low energy buildings. But the rest of this is really sort of beyond our kind of remit. So typically we're building, so we can do a bit about transport, we can make low carbon transport, but food, you know, 20% is about our food. Goods, that's that kind of things, our bright orange jumpers that go with our slide set, or whatever else it is. Services tends to be things like banking and pensions, so the things we don't necessarily think about, but we still invest in. Government is our kind of local councils, our, you know, parliamentary buildings, whatever else, those kind of bits that just come with it. And infrastructure. So infrastructure could be roads, could be railways, it could be the NHS, you know, all this kind of stuff that is directly related to us in a country. So in some ways, you know, nearly 30% of our global footprint is things we don't actually necessarily see, but they're always there. You know, that's our one planet worth. So it's very difficult in the UK to get below 1.1 planets. And even I think Sue Riddleston from Bioregional, who's Bioregional came up with One Planet Living, I think she's down to 1.1, which is incredible. I mean, it's absolutely amazing to get that close. So the One Planet Living framework is this really very broad, holistic, and this goes slightly further than global footprinting. And we use it internally on every project. The point behind this is that I mean, it's great to focus on carbon, and this does have carbon in there, so we've got zero carbon energy and materials and products. But really, the thing that we really like about this is these top three on the left here. So health and happiness, equity, local economy, and culture and community. What's great about this is it's not about just making low carbon buildings. It's about creating a sustainable society, a neighborhood, a community. You know, people who are able to support each other to those kind of aspirations. And how do you create a building or project or master plan that really works with that? I think is really incredibly key. Health and happiness. If we can reduce or improve people's health, we can reduce the burden on the NHS. If you reduce the burden on the NHS, we use less energy, so it all kind of works out. You can start to think about how these things have a huge impact. Equity and local economy, we can start to use fair trade items rather than a kind of soya from a rainforest in South America or wherever it's coming from. So really support these businesses that'll have bigger impacts. A really classic one we use as an example is sustainable food. If you give people access just simply to things like herb boxes on their balconies, it could still be high density, it doesn't need to be a huge allotment. People can grow herbs. Actually, they start to look for food they can cook. And when people start to cook food from scratch, A, it's healthier, great, helps our health and happiness. But B, typically they're supporting local businesses, they're looking at the greengrocers, or maybe, they're buying fruit and veg, rather than kind of packaged meals, which are a bit more speculative. And then people start to think about the food choices they're making in a bit more of an explicit way. If you're buying your kind of Findus lasagna, which probably used to have horse meat in it, you don't necessarily know what's in it. But if you're starting to build it yourself, you can choose between the different kinds of meat that goes into it, and you can start to choose. Do I get better meat or do I use corn? All that kind of stuff. So it's really good. And what's great about these is things. This is from oneplanet.com. Recently released, really very good way of mapping it out. This is actually our London office, some of the things we do in there. These things interplay with each other, so it's not just about isolation. You can really start to see that if you make certain decisions, you can have broader impacts on it. This is just a kind of bit from One Brighton. One Brighton was built in 2008, 2009, I think, so quite a while ago now. And it's the first housing project we used, or first housing project in the UK that used One Planet, and it's still there down by Brighton Station. And we had these kind of low carbon aspirations of it, so we used lots of timber. You can see that, and it's very sustainable. We use sustainable sourcing, but we integrate things like allotment gardens on the roof, so you see that an awful lot now. And we looked at things like healthy materials, so low VOC materials. But I think the thing that really interesting from my point of view, I think those kind of things are kind of standard now, but the things we're probably starting to really get into is, how do we construct that building and how do we make those benefits ripple out from this project? So the contractors use biodiesel. Now, still got lots of issues, but still much better than diesel. We probably now say they should use electric vehicles or something. We had a green travel plan, showers, lots of extensive bike parking for the contractors. A healthy canteen that is rumoured to be the best on-site canteen the practice has ever seen. It was sustainable food, it was fair trade and whatever else. We even gave the contractors membership of the local wildlife trust. Lots of people hadn't had that opportunity to really go in it. And this came along with the local history toolbox talks. Somebody came in every week and talked to them about the local area, talked about the flora, the fauna, what used to happen in Brighton. Really just educating people and giving people that opportunity to have those discussions. Really incredibly elegant and really nice way of doing it. So that is me waffling through FCBS in a very, very quick overview. This is a picture, actually, just before I forget. This is from our Carbon Counts exhibition. We set this up in our office in October, November 2019. It's still there because obviously we haven't really been in since March. But we've now turned it into a website, so you can find that if you go on the climate bit. And again, it's about that idea of just, how do you convey those information? So well worth a look. Again, we've got a bit of time for Q&A, but if there's anything else we don't get to, feel free to drop me an email. I'm moderately okay at responding. It's taken about a few days at the minute, but how it goes. Anyway, thank you very much.
Cheers, Joe. Thanks very much for that. A lot of ground covered. As you rightly said, Tom wasn't a plant, but that was a great question for both of us to promote our stuff. Funnily enough, Joe and I really, I guess, kind of, dare I say, kind of found each other when I heard about Joe's first efforts about FCB and or within FCB for doing the embodied carbon calculator, and that picked up on a lot of I got a lot of sentiment that we were hearing back from architects, where in those early stages, just understanding something, being able to put some kind of numbers or understanding what's good and what's bad, just at that primordial level, that wasn't available. So that really got me going, and obviously we've now got our calculators to a stage where we're more than happy to share those, and no doubt, as Joe said, as we get more definition about embodied carbon targets, there's LETI, CIBSE, the RIBA are working on basically, and the Greater London Authority working on agreed kind of cross the board targets for different building types. That will allow us to improve our calculators and to improve that information at an earlier stage. The question that I put up there, Joe, was about, I mean, we've both had this, where these are early stage design tools. I mean, given the fact that there's a massive vacuum for embodied carbon calculator tools, in your humble opinion, where do those, what are they good for and what are they not good for? When we talk about the phases of a design and being developed, where do they start coming under stress? And my particular question was, in your opinion, when should you start investing in more kind of serious professional tools beyond just an Excel spreadsheet that's been cleverly coded and presented?
No, I think this is a really key point. So we do use FCBS CARBON on completed projects to get an idea of where it's a rough idea of it, but it's not accurate enough to give us a proper figure for it. So we use FCBS CARBON on stage 2 because it's algorithmic and it's kind of designing an imaginary building. You can start to take them quite a long way. So Mesh Energy is a bit cleverer, a bit more accurate than ours, so it's worth a look. What I would say is things like HBERT, probably the next level, so it's getting slightly more accurate in terms of, it uses a BIM model, so it is getting accurate. Do be very careful when you use BIM models for embodied carbon. It really relies on how well you model them. If you've got things like solid walls and you say it's brick, if it's modeled as a solid wall, they will think it's all brick. You need to show all this kind of gap. So you do have to be kind of careful with it. Where you start needing to report on things, I think, is where you start really looking towards professional tools like OneClick or eTool or some of the others that are out there. And this is really when you start to be able to have a kind of robust bill of materials out, or a robust material specification. So where you're actually starting to say, okay, I'm not just picking any plasterboard, I'm using X plasterboard from this manufacturer and I have the EPD for it. So it is a kind of scalar thing. I would say there's always benefit in using anything, even these free tools out there. I know there's OneClick Planetary as well, which seems kind of fine. I've got much experience with it. And I did mention EC3. They're pretty good, but we see a kind of stage 3 onwards, we'd want to start pushing this back onto our engineers, who would probably be modeling this in a far more thorough way than we would. What we do find is up to stage 2 as an architectural practice, we're probably working by ourselves. So those kind of free tools are perfect to give us the direction, to give us the magnitude that we can sort of push towards. And then we can really start to interrogate it with, experts who can sort of push us forward. So that's where I see it. And particularly if you're modeling a building and you've got a full layout plan for it, and you're using one of these free tools, actually you're probably better off working out the bill of materials yourself by hand. Doesn't take a long time, or asking your QS, and then just going through and finding EPDs for it, go through the IC database. I think that's a really nice way of doing it. If you're looking to do things like BREEAM, you'll have to use the BREEAM approved software. It's not particularly difficult to get BREEAM approval on the software as long as you kind of meet their targets. So that's a key thing. If you're looking at things like the GLA, you'll have to make sure that your software and your tool meets the RICS guidance. So ours pretty much does, apart from the carbon sequestration. So that kind of caveat. So that's kind of how I see it. I do think stage 4, 5, you really need to be really using something professional.
Yeah, and I would, you know, I guess I would mirror that sentiment. I think it's always really tricky where, you know, everybody loves free, and it's certainly handy for those early stages. But if you're not careful, if you continue trying to kind of penny pinch as your design is developing, you're actually increasing the project risk, because you know, it's a bit like kind of the emperor's clothes, really. You think because this spreadsheet is telling you a number that's below the threshold that you've chosen, but as I say, as you get into the detail, you could be varying more and more away from where you think you are. So I think that blend is right. And as Joe and I were discussing before we kicked off today, every practice is different here, how they design sustainable buildings. And I think there's a great discussion to be had, and I'll ask Joe your opinion for this, but every practice is different. Every practice has a different design process, and how they get concepts out, and how they go into detailed design, and how they, you know, how much effort they put into planning. And I think where practices, I mean, net zero carbon is being banded around all over the place. I think people get it, but for those who think they're behind the curve, or really have a steep hill to climb as far as getting sustainability and that sustainable design process into their practices, what advice could you give about maybe some of the first stages that a practice which wanted to do something, and maybe they've declared that they're going to do something, just one or two key tips for what's the next phase to really get the business moving and actually getting them doing something practical things?
Yeah, big question. So I think the first thing is recognizing where embodied carbon is used. So because net zero, I think me and Doug were talking about this before, but you know, we have to kind of educate the entire supply chain to get this on. It's from clients all the way down to, you know, manufacturers of, you know, pumps and whatever else. So I think understanding where you can focus and where you get the best response from. So structurals, you know, if you can start to optimize your structure, so really lean on your structural engineers and really talk to them about how you can optimize it. Quite often we'll see things like it'd be an office building that wants a 15-meter clear span. Well, that's great. We can do a 15-meter clear span. It's not really a problem, but it'll be twice the embodied carbon of a grid that's, you know, 7.5 meter, something like that. So start to look for those kind of structural solutions and how you can kind of optimize it. There's a really good, if you go on the iStructE website, there's a really good bit of work by Bureau Happold. If you go iStructE, climb up Bureau Happold, I'm sure you'll find it, which just talks about how you can optimize it and really start to build those processes in. That will save you so much sort of embodied carbon at zero cost, you know, and quite often you'll have cost savings because you're building things more efficiently. That's the kind of first thing I do. Operationally, I would start to look at things like passive house. I am a passive house designer or consultant, whatever one it is, and passive house can be a bit culty. The thing I really like about passive house is the robust processing that goes with it. So you can start to say, what's the best way of looking at this? You know, when you're building things, everything is aligned with your kind of end goal of low carbon, low energy. So think about all of that kind of bits. What I would say is a kind of preamble to that is go back to your buildings and find out how they're performing. And if they're not performing brilliantly, why? And then don't do it the next time. Really, really simple. We learn an awful lot from that. And certainly quite a few easy lessons there. And it's a really good way of maintaining relationships with clients as well, if you're in that kind of design side. So those would be my 2-3-ish big things. that'd be kind of in a waffly way.
Okay, a couple of other questions here. Kate's asked about certification for net zero carbon buildings, and she picks up on a point here which we're familiar with, because we've got with timber and natural products, we've got the ability to add in sequestered carbon. She's rightly said, well, you know, is there a way of saying, look, you know, this building has been built to this standard by reasonable methods, rather than kind of offsetting and as you say, almost kind of playing the game, and all of a sudden you end up with a net zero carbon building, although it might not be, you know, cheating. How do you get around people cheating net zero carbon? And is there a certification that goes with that?
I'm not sure there is a robust certification at the minute, and it's not one that I've seen. What we're proposing, so I sit on lots of boards, so I sit on the LETI task force, and I'm Whole Life Carbon Network, and I'm sure others as well. And we're constantly talking about how we deal with this. Now, I know science-based targets are proposing a kind of 3 levels of net zero carbon based on what you're kind of, how well you do in the first place, and then your types of offsetting you're doing. So is it on-site offsetting or is it off-site offsetting? So I think that's the one. And it's out for consultation. It is getting there, but it's worth having a look at the science-based targets. It was only released, I think, 2 weeks ago, like this kind of consultation. So have a little look at it. But you're entirely right. So what we're proposing is everybody says how much carbon they're emitting, you know, operational and embodied, and then also how are you getting away with it? You know, what do you do for terms of offsetting? Really interesting, really kind of clever. Just make sure that people are always saying what they're emitting and then what they're saving. I think that's the kind of key. But yeah, there's not really a great sort of framework out there. I think Living Building Challenge might have something, but it's difficult in the UK, is how I'll put it.
Cool.
Yeah, I mean, house out of sofas.
Yeah, great. And these things will come along. You know, the pace is so rapid now that there's so many people talking about it. And that 3-stage thing is new to me, Joe. So I've learned something there as well. And Stephen's asking about, so let's think of kind of super small scale projects here, rather than office blocks and brand new schools and stuff like that, which are great and they grab the headlines. When it comes to extensions or, you know, existing properties, he's saying it's hard to get clients on board a lot of the time because of the cost constraints. So there's a drive to look at embodied carbon, but the client hasn't got thousands and thousands and thousands of pounds to become, you know, create a 20 square meter net zero carbon extension. What's the kind of a realistic either conversation to have or something to suggest which, you know, could make a meaningful difference without, you know, breaking the bank?
Yeah, so what we I think things like extensions are really good. There's an awful lot of work going into things like retrofit and how do you maintain buildings, so rather than building a new building. So it's a really key question, actually. Simple things like using natural materials like timber. Not only, you know, is timber kind of easy to work with, you can prefab it, so you can build it somewhere safe. You dump it in, you can build it really quickly, so you can save a lot of that kind of build time and the kind of disruption that comes with it. So things like, we have a big building that go back to a school. It was built out of CLT, but the only reason it's built out of CLT is to save time because it's all done off site. So you can kind of do these things there, and it doesn't have to be as clever as CLT. It could just be timber frame. The other thing that's really nice is if you use timber frame, and it could just be as simple as, you know, C24, you know, kind of carcassing material. It doesn't have to be super clever, and, you know, infilled with, you know, slap some insulation on it, slap some render on the outside of it, really quick, very reliable. You can get a very good finish with insulation with render on top, but it means you have less foundations because you don't have to worry about bedding in all of that kind of, you know, a nice level thing you put all your block work on. Actually, timber's so much lighter, you can get away with a lot easier foundation. So there's, you really think about those kind of, particularly where you're looking at extension, you know, it's somebody's home, you really want to minimize that disruption. So that could be a nice way of doing it. That would be kind of where I start to look.
Cool. All right. And we've got kind of a final question here. We're quickly closing down on 11 o'clock, but the final one, just a bit of food for thought. So the Future Homes Standard. I don't know how many people on the call are familiar with the Future Homes Standard. This is something that's gone through consultation. It's coming in the middle of the decade. And Mohammed's asking about whether you think the Future Homes Standard will go far enough to reaching net zero carbon or net zero.
I'm hopeful. No, I'm hopeful. They have been. there's lots of great noises coming out of places like MHCLG, who are writing the Future Home Standard. So it's got every chance of succeeding. What we see in the UK is that we don't tend to go above and beyond minimum regulations, unfortunately. So unfortunately, I think regulation is the way forward. The government is currently making loads of great noises about this, so fingers crossed. I know LETI and other groups are talking to them. I'm talking to them about embodied carbon. So yeah, maybe it'll get there. The only downside is previous governments have acted things like zero carbon homes in 2016. So we're already 10 years behind where we should have been. So it can't come soon enough. So yeah, it might make a difference. And regulation is the key way for the kind of UK.
Yeah, I mean, certainly, and I would just finish up by saying it's certainly the regs are certainly going to push down operational energy and carbon emissions and things. But you know, embodied carbon, I know the Greater London Authority are talking about introducing kind of embodied carbon targets as part of building stuff in the city. It kind of remains to be seen how far they go down that route. But invariably, there's going to be a lot of change in the next 12 months, the next 24 months, and by the middle of the decade, you know, a huge amount will have changed. Right, we're going to wrap it up there, guys. Thanks very much for your questions. A huge thank you to Joe for your time there and your expertise. As I say, we're going to be recording this. We'll bang this up on YouTube. And next week around, again, as Joe mentioned there, we've got Fionn Stevenson. She's written a great book on post-occupancy evaluation, definitely one of the leaders in the UK in the field of post-occupancy evaluation. And she's going to be talking about simple post-occupancy evaluation, not barrel loads of data. So definitely pitch in and check in that one out. I think you're going to get a lot from it. So for now, guys, thank you very much. And we will see you next week. Take care.
Great. Thanks all. Bye.
Bye.